right, let's start chapter 8, the second half of the year. It's going to be very algebra heavy, so you gotta keep up with the pace. And if you are not, if you feel deficient in any of the algebra skills, you should come to extra help so you can get extra practice in. Okay, so I'm just gonna give you the answers for this. If you can get to it, I want you to do them all, okay, practice, and then if you don't get to the answer, you have to ask questions, and you probably need to look back the radical packets, okay? So the first one is 5 root 2, the second one is 9 root 3, this one is 8, this one is 5 root 5 over 2, this one is 4 root 3, this one is 2 root 3, this one is 6 root 2, 8 is 6, 9 is 6, 10 is 13, 11 is 7 root 2, 12, 2 root 15, 13 is 2 root 6, 14, 2 root 2, 15, 5, 16, 6, 17, 2 root 17, 3 root 5, 2, 15 root 3, and root 5 over 2. And this is root 14 over 7. This is root 2. And 24 is 3 root 10 over 2. Okay, so make sure you can do that, and if you can't, then you need to practice. All right, here we go. So we have 7 sections in chapter 8. Similarity, Pythagorean, converse of Pythagorean theorem, and special right triangles, tangent ratio, sine. I think these are easier. This part is pretty hard. Okay, so we're gonna do a quiz after here. This is the part that you can use calculator. These I think you like them. These are not very hard. Okay, so 5 objectives for the first 4 sections, and objective 1 and 2 in this packet. So determine the geometric mean between 2 numbers. That's my dog playing. State and apply the relationships that exist when the altitude is drawn to the to the hypotenuse of a right triangle. Okay, all right, so those are 2. All right, take it easy here. All right, geometric mean, example 1. Recall that in the proportion a over x equal y over b, the terms shown in the red, I don't know which are the means, so these are red, okay, the means, and these are extremes, right, mean and extremes. If a, b, and x are positive numbers, and a over x equal x to b, then x equal the geometric mean between a and b, if these are both x. Okay, so these are called means, and if this ratio holds, then x is the geometric mean of a and b. It's because okay, let's read this first. Okay, if you solve the proportion for x, you will get the x equals square root of ab, because x square equal ab, right? So x is actually plus minus square root of ab. So that's what this is, a positive number. The other solution, x is negative ab, is discarded because x is defined to be positive, okay? Because x are positive numbers, right? So the plus minus ab is the answer, but the only one positive one is answer because x is defined as positive numbers. The way to think about it is if there is A and B, two numbers, the mean or the average is A plus B divided by 2, right? This is called arithmetic mean because you're adding and dividing. The geometric mean is instead of adding, you're going to multiply. Okay? And instead of dividing, you're going to take a square root. Okay? So this is called the arithmetic mean, and this is called the geometric mean. Okay? Geometric means are used in a lot of statistics and many other part of math. This is more familiar to most people, but geometric mean is also, it's just 1 degree higher. Instead of plus, it's multiplying. Instead of dividing, you are taking the square root. Okay, so that's geometric mean. Find the geometric mean between 5 and 11. So you multiply and take a square root. And geometric mean is defined as positive, so you don't have to do plus minus. Okay, so this would be square root of 55. Okay, all right, so theorem 8.1. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. We kind of proved this already because this is right angle, right? So if there's altitude, the hypotenuse, this is 90 degree, and this is 90 degree, and this is 90 degree. So this triangle is sharing the angle and angle, so it's similar to ABC. And this small one, this is angle, and then this is shared, so angle, and it's similar to the large triangles. So ABC with right angle ACB and altitude CN, these three triangles are similar. Okay, so we already know this. And the corollary to 1 and 2, when you set up corresponding side proportionally, then this is what you get. Okay, so when the altitude is drawn to the hypotenuse of a right triangle, the length of the altitude is the geometric mean between the segment of the hypotenuse. So this is the geometric mean of this and this. That's what this is saying. And then that's because AN, so this is the short leg of the small triangle, over CN, this is the short leg of the medium triangle, right? Short leg over short leg is, this is the middle leg, right? Middle leg of the small triangle over the middle leg of the medium triangle. So that's what this is. And then if you cross multiply, AN times BN is CN squared, right? So geometric means. Now these CN squared. These are the things that we did in the last chapter, but that it's coming back. Okay, so this means the CN is geometric mean of AN times BN, because if you cross multiply, that's what you get. So the hypotenuse is geometric mean this and this. So we don't need to do, well, we basically did the proof now. Corollary 2. When the altitude is drawn to hypotenuse of a right triangle, each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. That doesn't mean anything to you. But what this is that this is a geometric mean of this and this. And this is a geometric mean of this and this. Okay? So the middle one is a geometric mean of stub and stub. This one is a geometric mean of a stub and a hole. This one is geometric mean of a stub and a hole. That's what this is. Okay, needs a little bit of practice. This is how we teach in ACP because they don't like to understand it, but they like to memorize it. And some of you tend to think that way, so I'm just gonna give it to you. I would rather you set up a corresponding side and then learn it that way, then there's nothing to memorize, only understanding. But if you don't like that, you can use this way. Okay, think of this as a ski slope. Okay, so this is the green slope, right? And this is the blue slope, and this is the black diamond, right? So you're on the ski mountain, and when you're going down the Black Mountain and then you fell and you got injured. So you are right here at the bottom of the hill of the Black Mountain. And rescue station, it's Murphy's Law in life, and it's never near you. So they have to come from this rescue station and this rescue station. The rescue guys, there are 3 stations, but no one was at your station. So they have to come from here and here. So that's the geometric mean. If you are here, they have to come from here and here. You are down the blue slope and then you got injured. So you are here. Murphy's Law, there are 3 stations, but no one at this station. They have to come from here and they also have to come from here. So it's a geometric mean of this and this. The same thing if you go down the green slope and you got injured and you came to this bottom of the hill, no rescue guys here, even though there are 3 stations, someone is here, they have to come from here, and they have to come from here. That's kind of how we help them memorize, okay? All right, so here's example 2. How do we use that to solve problems? Use the diagram to find the value h, a, and b. You have to find these values, okay? So the h, you remember the black diamond, you're here, so they have to come from here and here. So this is the numbers. So h square is 3 times 7, right? You multiply them. Now, there's always someone try to do h square is 3 square plus 7 square. That's not what we're doing here. Okay, that's not what we're doing here. Oh, you know, you can do this. 3 over h is h over 7, right? Short over short is medium over medium. And then cross multiply, you get here. Okay, so if you get confused with the Pythagorean theorem, don't do this 3 square plus 7 square. It's something completely different. This is geometric mean. These are corresponding sides, cross multiply, you get here. Okay, so the h square is 21. So h is square root of 21. Same token, h, you're here, they have to come from here and here. So a square is, what was this, 3? Yeah. So 3 times the whole thing, 10. Not 3 times 7, you need the whole thing because they have to come from here to where you are, right? So again, if you want to do it this way, this is the short side of the big triangle, right? So a over the short side of the small have to equal so this is short over short, and then you need 10. So this is hypotenuse, right? So hypotenuse, so I did the stuff is a large triangle, small triangle. So large triangle hypotenuse is 10, small triangle hypotenuse is a square is 30. Okay, does that make sense? So a square equals 30. So a is square root of 30, and nothing comes out, okay? And the last one. So b square is this portion times the whole. And if you were to set up as a corresponding side, b, and you're looking at 10, right? So the hypotenuse and hypotenuse. So hypotenuse of the medium over hypotenuse of large have to equal middle leg of the medium over middle leg of the big triangle, right? So cross multiply, you get b square equals 70, and b is square root of 70, and nothing comes up. It's really, once you get used to it, it's quicker. Instead of setting this up, it's quicker to go, this is geometric, this, and this, 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 and this, this, and this. It's just really quicker to go straight here instead of going through this. I just want you to understand that it's coming from this. If you don't want to understand coming from this, just remember the ski slope analogy and go straight to here. Okay? So, I want you to do this, okay, at home, and I will tell you that w is 2, x is 16, and y is 4 root 2, and z is 12 root 2, Okay, so those are the answers, and since we need to simplify z, I'm gonna do this one. So you do D's homework, okay? So you want to find out z, okay? So this is, if you look at it this way, if that's easier, if you look at this way, right? That's like a green slope, black diamond, and blue slope, right? So this square is this times this, okay? This square is this times this. So z square is x times the whole thing, 18. Okay, and then x is 16, right? So z square is 16 times 18, right? So z is square root of 16 times 18. Now notice that I didn't do this, did I? I didn't multiply this, because I know that I need to simplify this later. So there's no point of multiplying and then trying to find the factor later. These are easy numbers to find factors, aren't they? This is 4 times 4, 16 is 4 times 4, and this is 9 times 2, right? So 3, 3, and 2. Remember, inside the radicals, if the two numbers repeated, they come out as a single number. So z is 4 times 3, and then what's still left in here? 2. So that is 12 root 2, and that's the answer. Okay? I wanted to get to these numbers though. Okay, so practice. And what else is there to do here? Alright, so the rest of practice. So these are all practice, and then it starts exercise here. So we have one more page to go in the video. Okay, there are a lot of these math, and then towards the end it's more problems, right? But this is a lot of doing drills in this packet. Okay, so simplify, practice here. Okay, and you can do this. So why don't you do where am I? This looks different. Oh, here it is. Alright, so I wanted to do odds here. Homework. Okay. I don't think we need to do any geometry. We can multiply and take a square root and simplify. Okay, I think you can do this. Okay, so odds including 15. Alright, do this. So T is geometrical mean between S and R. You don't need to do this. It's too easy. Well, do it if you wanna, but you know, this is geometric mean of this and this. This is geometric mean of S and K. This is geometric mean of R and K. Okay. So why don't you do 17? Okay, homework. It's really, if it's set up this way, it's easy to know. If it's a little bit oriented in a different way, it makes it sometimes harder. So you know, if it's easier just to put it the way that you can see it better, but once you get used to it, these are not hard problems. And the rest is exercise. Alright, so that's it.